Hello guys, welcome back to another video on machine learning series. So today we are going to talk about support vector machines, which is a supervised machine learning algorithm used for classification as well as regression tasks. So this is also useful whereas when we are working on any classification problem as well as regression tasks. So basically, the support vector machines is nothing but. Uh, so we are going to talk about few terms, which is hyperplane and support vectors and what is margin, something like that. So first, let's talk about hyperplane. So hyperplane, nothing but support vector machine tries to find the best line. So here, for example, in the below image, you can see that so these are all my data points and these are all my another set of data points. So the line which separates the data points from different classes. So let's call these all yellow points as my class A or A class. Let's call all these green points as class B. So the line which is separating uh, data points based on their classes. So that is nothing but a hyperplane. So SVM tries to find the best line in 2D. In 2D, we can call it as a line, the line which separates the two classes of the different data points. For example, in the below image, the line which is separating a class A of yellow data points and class B of green data points, something like that. So this is just an example. So that is what a hyperplane, a best line or hyperplane in higher dimensions. So the same line we can call it as a hyperplane in higher dimensions. So this is about 2D only when we have 2D like x-axis and y-axis. But when we are working on higher dimensions, like if you have x, y, z, 3 dimensions and 4 dimensions, 5 dimensions, something like that. So in those dimensions we call this line as a hyperplane that separates the data points from each classes. So here in the below image we have a clear picture of a hyperplane, how it separates the different classes of the data points separately. Like this is called a hyperplane in multi-dimension since we have x, y, z. So it is a 3D image and I have two classes of the data points and my hyperplane is separating the two classes. So this is called a hyperplane in 3D and a line in 2D. So that is about hyperplane and support vectors. So support vectors are nothing but these are the points that are closest to the hyperplane and influence its position and orientation. So let's take if I take this is my I mean hyperplane. This is my hyperplane and the nearest point of this class and nearest point of this class which are nothing but support vectors. So these are the data points that are closest to the hyperplane and influence its position and orientation. And these points are critical in defining the hyperplane because the algorithm aims to maximize the margin around them. So this margin around the data point of respective classes. So that is about support vectors. Support vectors are nothing but the data points which are closest to the hyperplane. So that is a simple, and margin is nothing but the distance between the hyperplane and the nearest data point. So for example, this is my nearest data point and the distance between the hyperplane and the nearest data point is nothing but a margin. SVM seeks to maximize this margin, which helps in achieving better generalization. So that is about hyperplane and support vectors and margins. So we're gonna talk about all these three terminologies when we are working on any data or any classification problem. If I wanted to classify by using this support vector machine algorithm, so we're going to talk about this hyperplane, support vectors, and margin. So that is our discussion about the support vector machines. And also, so if So we do have two different types of data, like a linear SVM and also non-linear SVM. For linear separable data, SVM finds the optimal hyperplane that separates the classes with a maximum margin. So like if so this is, if I take this is my linearly separable data. So this is how the data can be separated with the support vector machines with a margin. And if I have non-linear support vector machines, when data is not linearly separable, and support vector machines uses a technique called the kernel trick to transform the data into higher dimensional space. So when the data is in not a linear form, linearly separable, and if it is in a non-linear form, then this algorithm SVM uses a technique called kernel trick to transform the data into higher dimensional space, where a hyperplane can be used to this hyperplane can be used to separate the classes. So common kernel include polynomial, radial basis function, RBF, and sigmoid function. And effective in hybrid, I mean, the advantages of this support vector machines is nothing but the effective in high dimensional spaces. Support vector machines is effective in cases where the number of dimensions is greater than the number of samples. Memory efficient also, it uses a subset of the training point in a decision function support vectors, making it memory efficient. And the versatile nature of this algorithm, different kernel functions can be specified for the decision functions, making it versatile in terms of decision boundaries. And computational intensive. Training time can be long for large data sets, not suitable for large data sets. So these are like disadvantages of the model. Training time is very huge, like when we are working on a larger data sets, and not suitable for larger data sets. SVM can be less effective on very large data sets. Choosing the right kernel. The performance of SVM is highly dependent on the choice of kernel and its parameters. And the applications of support vector machines are text and hypertext categorization. SVM is widely used in text classification and categorization, image classification. SVM is used for image recognition and classification tasks. Bioinformatics, it is used in medical diagnosis and expression classifications. So this is another example how this SVM on linear and non-linear data. So this is linear SVM and non-linear SVM. So here you can see the my category A data points and category B data points, and this is my hyperplane. Or if it is a 2D, since we are I mean, since it is a 2D data, I can call it as a line which separates the category A, category B, and these points which are very close to this point is are nothing but the support vectors, and the distance between the uh, this line and the support vector is called the margin. This is the margin and this is the line, and these are all the support vectors for a linear. And when we are working on a non-linear SVM, so this is the my hyperplane. So exactly it looks like this when we are working on a multi-dimensional data. So my data points are here, one category and other category here, and the line which separates the two set of categories is nothing but a hyperplane. So this is a brief chart how the algorithm works. The training image descriptor, and predicting the vector, and training result SVM predictive result, predict image, something like that. So this is how the model will work, the flow chart. So let's work on a data set. Let's understand how exactly we can import this algorithm and how can we work on a practical data set. So I have a digits data set, handwritten digits. So for example, here in the image, you can see digits are written like number 2 like this, and number 1, and here something written, and this is number 3 for this. This is also 1, this is also 1. So I'm just importing these kind of data sets to the model, then machine will train and it will predict the numbers based on the training data. So basically why we are I mean, feeding the training data set, and then why we are passing a testing data set to understand the patterns. So basically, so as a human also, so when we are kid, when we don't know anything, then I mean, we need to understand, okay, when we look at the dog, okay, we can store that image of dog and that sound, how he barks, and also so we can able to memorize, like, okay, in going forward, that when I see the dog first time, I mean, my memory got stored with the certain characteristics, like, okay, dog look like this, and it barks like this, the sound it is something like this. So that memory got fixed. Similarly for other things also, when I see a cat also. So that is what. So for when I see first or second time, I'm just memorizing, or I'm storing that memory in my like in my mind. The second time, if I see the same animal with the similar features, I can able to recognize, okay, this is dog, and this is cat, and this is cow, something like that. In the similar way, we need to train the machine with a understandable language. So here I have a already existing data set, and I have also the targeted or results, and I'm just feeding the data, training data, so that the machine will understand the patterns with this characteristics. Okay, this is the output with this characteristics. Okay, this is the, okay, digit 1, digit 2, digit 3, digit 4. Machine will store this entire training data. So when I pass the testing data, similar characteristics or similar like features, and if I pass it to the model, once we are done with the training, then machine will tries to figure it out. It will match with the trained data. Okay, how, what are all the patterns? So if we are working on these kind of features, okay, this could be the my target variable, or this could be the result, something like that. So this is how we will process the memory based on the features we collected earlier. So in the similar way, machine will also recollect the information from the training data. So that is why, that is the purpose of doing training and testing data set, splitting the data set. So this is about this is a sample image of handwritten digits. So let's import the data set. So this is the inbuilt data set from from sklearn. So I'm just importing from sklearn dot datasets, importing load digits, and I'm importing pandas and numpy. So I'm just importing the data set. I'm defining my data frame, data, and this is, and I'm defining my target variable as target. So this is my data set, which has pixel 1, 2, 3. So these are all the values. So, and we do also have a target variable like with this pixels, and this is the target. Okay, if my image has this characteristics like pixel 7 with 0, pixel 7 2 with 6, it will be categorized or classified as 0. Or if my image has these characteristics, which will be categorized as 1. Similarly, 2, 3, 4. So this is my data set. So I need to pass, or I need to split this data set into training and testing part. So in training part, machine will learn the patterns. Okay, this characteristics, okay, this is target, or this is marked as 0. With this characteristics, this is marked as 1. With this characteristics, this is marked as 2, something like that. Machine will learn, and machine will able to guess the, I mean, new targets with the new features with the given training data. So let's talk about this data pre-processing, because this data in some pixels. So we must convert this data into a standard scale. I mean, we need to standardize the values. So I just use standard scalars and fit transform function. Then, so this is my transformed data. Now I can able to train the model with this data. We cannot able to predict, or we cannot get accurate results if I directly feed this data. So I have to pre-process it to get the accurate results. So this is my X label or input features. And now I'm splitting the data into training and testing part. So obviously I have to import train test split from sklearn model selection. So this is my train test split. So I'm giving 30% for the testing and 70% for the training. So random state I'm giving 42, and now I'm training the model. So I'm importing sklearn.svm importing svc, so model is equal to svc. I'm so the model dot fit, when I pass this training data set, then the model will be trained. It is ready to predict. So now we need to make the predictions. See, for every machine learning algorithm, the coding part is very simple. The important thing is the theoretical part and how we are able to understand, how we are able to apply the suitable machine learning algorithm as per the problem statement, and also as per the given data, and as per the features we have, as per the target variables we have. So that is how you can choose the machine learning algorithm as per the applications and how it works, which is a suitable one. If I use, because in classification, in regression, we do have a lot of machine learning algorithms, so which one is giving accurate results with the precision, so we need to select. So same thing, we have, say, every algorithm has train test split, and every algorithm is able to predict the results. But how accurate the model is predicting? So that is what here I am predicting the results. And if I wanted to see the, or if I wanted to evaluate the model, so here you can see I'm getting 100% precision for zero digit, and one also 100%, and two digit I'm getting 94% precision, 98% for three digit. So similarly, if I talk about the entire accuracy, I'm getting 95, sorry, 98 percentage of accuracy. That means my model is behaving, or my model is trained well. I'm getting a accurate 95% is nothing but which is giving a very good results. So that is how we can evaluate the model. So basically here the SVM categorizes the, like, number one, number two, number three digits, handwritten digits based on the pixels data input features. So if I wanted to test with a new data points, so this is my new data point. I'm just passing a new data points, and I'm predicting new target variable. So this is with the given data set, my machine is saying that, okay, this is for the digit 6. So if I wanted to draw or actual versus predicted values, so here you can see almost all are overlapping. Like for digit 8, the actual versus predicted, because my machine is giving 95% of accuracy results. So that is the reason why the predicted and actual values are almost the same. So this is how we can work on a classification problem with by using support vector machines. So when we are working on a classification problem, so this is how we can work on support vector machines. So I hope by end of this video, you'll be able to apply. So when to apply a support vector machines algorithm, and what are all the applications of SVM, and what is a hyperplane, what is a margin, and what is support vector. So I hope you got a nice idea with this explanation. So if you have any further questions, feel free to comment on the video. And if you really like the entire video, please do like the video. If you wanted to, I mean, if you want me to cover the further videos on machine learning or anything related to the data science, please subscribe the channel so that I'll be able to, it will motivate me to do further videos on data science and machine learnings. So thank you guys for watching. Bye.